Hi everyone, welcome to another Julia language tutorial. We're building an image puzzle game, and last time we've seen how to use the images, and we've ended up with visualizing the image using the imshow function from the image view package. Today we will start building the app, and we'll start with the opening view of the game, which is basically a scrambled image of the image. Which the user will need to interact to solve the puzzle. We'll finish this video with defining our first Julia function, which is a great way of reusing the code and encapsulating it in a generalized way. So we'll start with a more realistic image. We'll use the test images function for a package for this, and we just call it with some type of string that it knows for the images it knows for. So I'm bringing the image called Fabio. Its size is 256 by 256. You can also check the length of the image, which is actually the width times the height. And now we want to scramble the image to a new shuffled image. Just to understand, we can't do it in place because we don't want to override the data we will need to use. So for simplicity, we'll just define a new variable for an empty image or a black image. So we'll use the RGB type, the size of our origin image. There are more efficient ways to do it, but this way we just got a totally black image in the same size that we need, and we'll define it as our target image, where we will bring crops from the source image and paste it on the target image in a scrambled way. So this is what we'll use. For our toy example, we'll use totally 4 blocks, 2 in each row, 2 in each column, and we'll swap them around like counterclockwise. We'll do it hard-codedly just to get the point of it. So I can define the slices or the ranges, 2 blocks, meaning each block is 128 bits, and we can assign the slices to be from the first pixel to the 128 pixel, and from the 129 pixel to the end of the image. So actually, Julia's all about expression, and you can assign an expression to everything. So the type of B is a unit range, and we just assigned it to B1. So it's a range thing inside B1. And to shuffle the image, we just need to assign the portions in the target image, the shuffle image, with what we want from the source image. So to allocate the bottom left corner, we can bring the top left corner from the source image, like this way. It's a counterclockwise thing we're coding here. So the top left is just here, and just to do another one, we can define the bottom right corner to be given from the bottom left from the source image. And let's just show it. Shuffle. Yeah, so we've just allocated 2 blocks, but we need to see that our methods or way of thinking works. So yeah, you can see the eyes, which were previously in the top left corner, are now drawn down, and the chin and the neck are moved to the right. So yeah, it looks fine to me. We can start generalizing stuff a bit more. So first off, let's define everything in variables just to get the hang of it, just before we're coding everything into a function. So first off, we define the number of blocks. So we said the number of blocks. Let's say now there will be 4. Previously there were 2 blocks. So number of blocks let's just say it's the same number of blocks in the rows and in the columns. It will be simpler just to get the hang of it in the first time. And the block size, you can calculate the block size out of the number of blocks, and the block size is actually given by the size of the image, and let's say the amount of rows in the image divided by the number of blocks. So this is floating point 64, and this is not exactly what we wanted, because we'll use this in defining the ranges, and we don't want us to be subpixels. We need to do full ranges, so we'll just cast it to an integer. Next up is the slices themselves, the b1, b2. So we'll create it using a list comparison. It's a way to build the array during iteration. So let me write the formula, and then I'll explain the formula. So it's I times the block size plus 1 to I plus 1 times the block size, and we want to iterate for I to be from 0 to number of blocks minus 1. So we've got a 4-element array of unit ranges, and you can see that the end of their range is always a perfect multiplication of the block size, 64, 128, and similar. And the beginning of the range is always one above the starting of the perfect multiplications. And this is exactly what we've written. Just notice that we're iterating from 0 and not from 1, so we need to end at 3 rather than in 4 in our case. The next thing is we can define our origin or source blocks. So the blocks in the origin image, we'll define it again using a list comparison of x and y's for y in slices, for x and slices. So it's a 16-element array. Let me just reshape it so we can understand it a bit better. Blocks is equal to reshape blocks, and we can specify the number of the first dimension, so it's number of blocks, and the second dimension number of blocks, so it's rows then columns. Yeah, so now we can see it in a more organized way. So this is the top left block. This is the one below it. You see the first range in the tuple, meaning the rows are now a bit higher, which the columns are stayed the same. You can access this array using to index. So to index the second from left and topmost block, you get it topmost block, second to the left, and it should be this one here. So Julia also supports single index indexing in array, and Julia is what they call the row major, meaning they're counting the rows first. So it's this if we'll give, I don't know, like blocks of 5, so it's 1, 2, 3, 4, 5, meaning it iterates first through the rows, and then to the second column iterates all the rows, and so on and so on. So this will be the same as before. This is the same element as this one. Yeah, excellent. And finally, we want to define the target of the blocks. So we want to use some kind of randomize on the target blocks. So we'll use using random. Random is a built-in package in Julia. You don't need to add it or download it from anywhere, and it includes the shuffle method. So shuffle blocks is actually will be shuffle blocks, and you can get randomized permutated version of shuffle. If I run it again, it will be shuffled again. You can see the values are different, but the same values from our blocks are here. So we'll just define it as our target for the shuffle image. I think we can start building our function and understand what will do. So to define a function, you need to use the function keyword and set a name for the function. So function init game, and it will give it two arguments. One is the image, and the second is the number of blocks you want to use. This is the first. Actually, I think number of blocks we can define something more nicely. We can have it a positional argument, which means it's not a mandatory argument, but you can give it. So it has a default value of 4, and we need to distinguish between the mandatory arguments to the positional arguments with a semicolon. So this is defining a default value for number of blocks, and just as we defined before, we can define the block size to be the int of size of the image in the rows divided by the number of blocks. Yeah, and next is the slices. So the slices is equal to, again, the same formula we had as before. So it's I times block size plus 1 to I plus 1 times the block size for I and 0 to number of blocks minus 1, and the blocks is again as we defined it just before. Blocks is equal to xy for y in slices for x in slices. Now we can define the target. So again, shuff would be zeros of, and to just make it a more general way, so element type is actually the type of each element in the array. So the type can be RGB as we used before, it can be gray, it can be anything we want, and the size of image, and the shuff blocks is shuffle of blocks. So now we want the full assignment of origin from source to target. So we'll iterate for the entire blocks array. So for b in 1 to the end of blocks. So actually blocks is now an array, not a matrix, but we can still transform it to a matrix and it will work the same as we saw before. We can use a single index also for 2D arrays. So for b in, we want to assign the value of shuff blocks, the block in position B, and the rows values for its block, shuff blocks in position B, and the columns, and we can assign it from the origin image in blocks B Yeah, and we can end the for loop. So just before ending the function, we need to return something from the function. If we will run the for loop, nothing will return from the function. We can return using the return keyword, or simply calling the last value we want to return. Just remember that Julia always executes the last line, so this will actually return the value of the shuffle image. Yeah, and we've created our first function, generic function, with one method, and we can test it. So let's test it with 8 blocks. So new is equal to init game with our input as image, and the number of blocks would be now 8. Yeah, and we got something. Show new, and we should get a scrambled image with 8 blocks in each, 8 blocks in the rows, 8 blocks in the columns, and it looks nice. Excellent. I think we can create something even more generic for this function. Let me first just delete the end so it won't end the compilation as we go. So first off, I think the best way of dealing and understanding Julia is we need to define the exact type we need to run the function of. So you can see that this is actually of type integer as we specified, and the image is a more complex type because it's an array, but the values of the array can be changed because you can use a grayscale image, you can use an RGB image, you can use I don't know, BGR, or all sorts of types. So it's not a hard-coded type. We call it a parametric type, where we defined T to be each of the colorant abstract type. So if you remember, colorant is the abstract type, the highest abstract type for all color types, for all of the images, the pixel types. So this way we define the function to be acceptable for any image, and T would be the actual type of the pixel. Another thing we can see that we can actually, we don't want to hard code or specify only rectangular blocks. We can use a number of rows and columns can be different. So let's define number of row blocks to be 4, and also the number of column blocks to be an integer of 4 in default, but this is not mandatory. So now for the block size needs to be 2 values, one for the rows and one for the columns. So we need to divide it by the number of row blocks and the number of column blocks, and because it's actually tuple divided by a tuple, we need to broadcast everything. So we'll broadcast the integer type and the division, and slices also need to be changed a bit, because slices should be now each slice for each row and for each column there are different slices. So let's edit the row slices. So the row slices need to use the block size for the first argument, which is the row, and also here, and the number of blocks should be the number of row blocks, and for the column you need to do everything pretty similar, and number of column blocks. And for the blocks, so now you see why we have this one like this, and for row slices, so this is the order we should go for, and this is it. We can end the function. So now you can see that init game actually has two methods now. To see them, let's use the help of the Julia REPL. We'll start by starting the line with question mark, and the REPL will go to help mode, and we can see the help for the init game. So it has no documentation, but it knows it's a function, and it knows it has two methods for init game. One uses the image and number of blocks, and the other uses an image of type of some parametric type, and also actually two additional positional arguments. We can now view we can test our new function. So let us call new with init game, and maybe define only the number of columns. So let's say number of column blocks to be, say, 2, and imshow new. And yeah, you can see our blocks is actually only the aspect ratio is not perfect, and 2 blocks in each in the columns and 4 blocks to the rows, and the eyes got perfectly matched in this shuffle. Okay, so I think we had some great progress this video, and we covered so much. Next time we'll show how to start the game, and we'll talk about modules and scripts and how you can do it. Don't forget to comment below and let me know what you think, and don't forget to subscribe so you can get notified for new images coming out. Thank you very much. Hope to see you next time.